The last archives we will look at today are sediment records. Two important sediment records come from the oceans and from lakes. Many proxies are preserved in each of these archives that tell us about past climates and the impacts of climate change. Ocean ships are used to collect sediment archives from the ocean floor. These records can be hundreds of meters and millions of years long. Preserved in marine sediments are many proxies, including foraminifera. Foraminifera, shown here, are microscopic organisms living in the ocean that have a shell composed of calcium carbonate. Like oxygen isotopes in ice core water, oxygen isotopes in the calcium carbonate of the forams can be used to reconstruct past climates. Two key proxies in ice cores are foraminifera and radiolarians. Both are microscopic organisms that live in the ocean. We actually talked about both of these earlier when we learned about geologic processes in the carbon cycle. The isotopic composition, changes in species assemblages, and the elemental composition of these organisms can be used to determine past climates. In the 1960s, marine archives provided the first evidence to support Milankovich's theory of ice ages. The findings were reported in Time magazine, albeit this cover is a bit misleading. This slide shows the remarkable similarity between oxygen isotope data from ice cores and marine sediments. Although the isotope data from the ice cores is tracking temperature, marine sediment data, isotope data is tracking ice volume. Again, they show remarkable similarities. This slide puts together everything we've talked about today. The upper panel shows how the Earth's orbit has varied over time. The black line in the middle shows how these variations in the Earth's orbit affect incoming solar radiation at 65 degrees north, the latitude Milankovich thought most sensitive to orbital variations. The lower two panels show marine records of ice volume change and ice core records of temperature. This evidence helps us to understand what drives glacial and interglacial cycles.